Before we start the exercise 2.4, you should understand what is BCD value. BCD value means binary coded decimal number. Okay, we're using a binary number to storage a decimal number. What's the result? Only 4 bits will be used and not in a full range. It's only value from 0 to 9 only. Okay, if more than 9, that means you're using the another element to storage the upper significant digit. Okay, like 10, it should be one element storage 1 and the other element storage 0. So you can get understanding with more detail from the attached link. Okay, and this is one of the solution to transfer make conversion between binary to decimal to BCD. Okay, not difficult, but please read it carefully, and also have some link you can be studying more. Okay, for exercise 2.4, we need to do a counter, a 3-digit counter, a 3-digit BCD counter. That counting showing 00, then 1, 2, 3, 4, 5, something up to 999, then go back to 0 again. So we're using a binary counter and have a range control within 00 to 999. Okay, then do the binary to BCD conversion and put into our display memory. So our display memory actually also is in BCD format. So you need to do this conversion, and then your display background subroutine can show the contents of this value accordingly. Okay, let's see the result. Okay, this is the first program. Okay, reloading in. Okay, when they are start. Okay, now it's loading. Okay, the red light is gone. So we are starting, but the counting speed is really fast because the delay time is quite short. So I increase 10 times. So the counting speed will slow 10 times. But there is a problem. It's quite not stable, the display. The figuring is really large. So I take a middle 20, see what happened. So still have figuring, but the counting speed also increased. So it's quite difficult to adjust lighting this structure. But don't worry, we will have another solution. Okay, recording that is our event counter. Okay, that EV already happened in your previous exercise. Okay, it's not strangers. We increase the EV counter every time by time. That's after the EV counter have 15 times, then we can start with some pause. That means we have another domain based on the EV counter that we can control the task, condition of the task to activate or trigger. So every 15 times we count up and extract. We don't need to extract, convert the BCD to convert to the BCD conversion every time by time. We have a context update with the counter, the CNTR. Then we need to update the BCD code accordingly. Okay, so we take a look with this version. Okay. Now the delay time is only 5, so the display should be quite stable. Then the counting speed is reasonable now. So if I increase 10 times, that means the counting speed will become slower and slower. not this one, sorry. Yeah, delay time cannot be, we didn't make the change. Okay, this is 25, now is 15. Okay, so the counting speed will become slower, a double. Yeah, that's fine. Okay, although we can be increased more by 100. So a slower counting speed right now. So we can have a better display. Okay, maybe this is 2. But you can see the counting speeds also increase a bit because delay is a base time. Okay, the whole loop, how long with 1 to be passed, most likely controlled by this delay. If a longer delays, that means the base time will become longer. So if you want a correct counting speed, you need to confirm which delay that you want. That means actually you can know display, okay, because overhead of those statement is quite large already. But the delay time should be as large as possible because that will be make the overhead become less significant. Okay, if you have a 1 second delay, although the display will not good, but for example, if you have a 1 second delay, those statements just maybe 10 milliseconds, so it's not a significant effect. Okay, but so that this could be 20. Okay, and then you can adjust these two variables, then you can get a correct one. Okay, 20 is too small, so I changed to 10. Oh, seems good. By my vision is okay, but for camera it's quite sensitive, so maybe tune to 5. So you can see a very stable display even through the camera. And then you can adjust the event counter, okay, to adjust them. Okay, if you want each count is 1 second, you can adjust any value to tune up. But don't hope that it will become very accurate, because although delay is using a timer circuit to generate and peripherally inside the microcontroller, we will talking later, but don't think this will become a very accurate timing. Okay, it's just a reference. Okay, then we can take a look with next. Okay, actually now we have 2 tasks, background and foreground. Okay, background is your display. Every time you load, unconditionally will run once time, and we have some delay. Okay, and if under some condition, this task counter increasing will be performed and extract to the display memory. Okay, so we'll be do 2 tasks and 1 2 and 1 2 and 1 2. That is a simple multitasking already, and we can using some timer to do each task. But sometimes if the task is too long, that will overflow so we need to make some adjustment to handle it. Make sure that all the tasks should be smaller than the time slot. Okay, so people will be, but it's not utilized like that. This is waste. Okay, the overhead will gone. Okay, it is very important resources, so people will be using a larger time zone and do multitasking inside, not using time sharing like that. This is time sharing. Each time slot do one task, and this one slot doing all the tasks. But also have some assumption. All the tasks should as shortened as possible. So this is a flow chart that you can get more easy to understanding by this, because this that have a lot of condition. Okay, so the background task is your display subroutine, and task 1 should be your increment speed. And the other, after a very long time, we will clear with the counter value like an auto reset. Okay, so we taking a look with that. Okay, upload it. So now we are counting, but up to certain second, near to 100, they will reset automatically. Okay, because it's based on event counter time. So if I changing the up counting speed, the reset time should be same. So it count up to 15, they will clear. It will clear. That's right. Or I can be increase the clear time double. That will close to 100 to clear. That's right. So all the tasks can control more easily. Okay, you should say this is task 1, this is task 2, and most likely they have an individual event counter. Okay, sometimes I will writing event counter in a, if I have a lot of tasks, I will create an array and using for loop to make the increment, because event counter we need to increment every time by time.